All right, so Michelle, what I thought I could do is give a quick overview of working with this normal distribution. And then we can do some specific examples, okay?
Okay.
Actually, before I do that, maybe I should talk about the uniform distribution. So, you know, when we're talking about a distribution, what does that refer to anyway? You know, we talk about a normal distribution and a uniform distribution. Well, it really has to do with, you know, if you can kind of think of a histogram. So here's the normal distribution. Let me think about IQ scores. Well, the average IQ score turns out to be about 100. So if I was to draw a histogram, this would be like the frequency of occurrence, and this would be IQ score on this axis, let's say. Well, most people have an IQ score of 100, so that would be like the tallest bar on this histogram. So this would be an IQ score of 100, right? So this is like saying most people have an IQ score of 100. As I start to go to the right, like 110, 120, 130, 140, fewer and fewer people have higher IQ scores like that. So these bars are going to kind of go downhill like this. Well, the same thing for lower IQ scores. Let's say IQ scores of 90 or 80 or 70 or 60. Fewer and fewer people have lower IQ scores. So that's where we end up with this bell-shaped curve. We call this the normal curve. It's kind of a distribution of IQ scores where most people have the average of 100, but then as I go to the right, fewer and fewer people have higher IQ scores, fewer and fewer people have lower IQ scores. So there's a lot of measurements that follow this kind of a pattern. Things like salaries, right? Most people make a kind of an average salary of, let's say, $50,000. Much fewer people make high salaries, and much fewer people make low salaries. So salaries tends to follow this normal curve. The same thing with, let's say, the height of males. Right, the average height might be, let's say, 5 feet 6 inches tall. Most males have a height of around 5 feet 6 inches tall. Many fewer males are very tall, and many fewer males are very, very short. So this is the kind of distribution where you have a common measurement, it's called the mean, and then as you go to the right or the left of the mean, the frequency of occurrence goes down and down. So we're going to talk about that in a second, but there's another kind of histogram called uniform. What uniform says is the frequency of occurrence is about the same. Notice it's kind of like this flat curve. And this would be whatever it is we're measuring. And so you could see here in this diagram, what this is trying to show you is that this is a uniform distribution. Let me think of an example where the frequency of occurrence doesn't matter for whatever it is we're measuring. Let's say I was measuring the attention span in minutes of six-year-olds. Well, most 6-year-olds might have about the same attention span. So there's not much variation about 6-year-olds. So this would be like a constant value. All right, now let me scroll down a little bit here in the textbook because there's some different parameters associated with this normal curve. Notice it says if you want to know the mean, you take a plus b over 2. And if you want to know the standard deviation, you take this messy square root. So let me go do an example here for the uniform distribution. Now, what is this a and b that they're talking about here? Well, a is the lower limit and b is the upper limit. So in our example here, the way I would set this up is, oh, hi, Gypsy. Thank you for joining.
You're welcome.
Yeah, can you see my screen okay, Gypsy?
Yes.
Oh, great. Okay. We're just starting on some homework problems. And so I thought we could start with problem 2 on the uniform distribution. So I'm here. Go ahead, sorry.
Oh.
All right, so let's look at this one. It says here, let's find the mean and standard deviation for this first example. It says U 1, 10. Well, what this is really telling you is for this uniform distribution, whatever it is you're measuring ranges from 1 to 10. So we call this A, and we call this B. So in this notation, the first number is the A value, the second number is the B value. So they're asking us to find the mean. Well, according to this formula over here, it says if you want to know the mean, just take A plus B over 2. Well, in our example, that would be 1 plus 10 over 2. Well, that's 11 over 2, which is 5.5. So the answer here for this mean would be 5.5. All right, let's go to standard deviation. Well, here's the formula for me to plug in for standard deviation. It says if I want to know the standard deviation, take the square root of b minus a squared over 12. By the way, folks, I'm recording this, so you don't have to worry too much about writing a lot of stuff down because you can always just go back and watch the recording later if you want. Well, I'm just going to plug in the numbers here. Our b number was 10. Our a number was 1. And now I could just work this out. So this is going to be the square root. Let's see, on the top here I have 10 subtract 1, that's 9. So that's going to be 9 squared over 12. But 9 squared is 9 times 9, that's 81. So that's 81 divided by 12. Now I can just work this out on my calculator. If you go to your calculator and go to the square root button, you can just enter 81 divided by 12 under the square root button. And if you work this out, I'm getting the result 2.59807. But I notice the homework problem says round the standard deviation to 4 decimal places. So that means I have to round this to 2.5981. Does that make sense on this one? Folks,
Yes.
let me know anytime if you have a question, please either use your microphone to ask a question, or you can also use a chat here in this Zoom meeting. But either way, ask questions if anything doesn't make sense. All right, so this is a uniform distribution. I think there's really only one question in the homework asking about this. So let's go to the other main topic, which is working with the normal distribution. All right, now, before I get into the homework questions, I'm just going to do a quick review of a normal distribution. So, you know, I was mentioning IQ scores follow a normal distribution. Well, this is the general shape of a normal distribution. Sometimes we call this a bell-shaped curve. Right? It kind of looks like the side of a bell. So we call it a bell-shaped curve. So let me give you a quick example of how we're going to answer questions using this normal curve. And really, folks, the best way to go here is to use Excel. Because Excel has some built-in commands that allow you to find these areas under the normal curve. So let me give you a quick example here. Let's go back to IQ scores for a second. All right, I'm going to give you some facts. So given the mean IQ score is 100. The standard deviation, that means the spread of IQ scores, is 10. You might say, well, where are these numbers coming from? Well, for right now, just assume that these are given to you. All right, well, if I was to plot this on a normal curve, we always put the mean right in the middle corresponding to this peak. So I would mark the mean right here in the middle. Our mean is 100. What I'm measuring is IQ scores on this horizontal axis. All right, so let me give you a question. Here's a very typical question that you might come across. What is the probability that a random person's IQ score is less than 85? Okay. So here's a question. What's the probability that someone's IQ score is less than 85? Well, anytime you want to find a probability, that is equivalent to finding an area under the curve. So we're going to want to find areas under this normal curve. Now, it's always a good idea to shade in or sketch the area, because if you can visualize the area you're trying to find, that's a big help. So here is the IQ score of 100. Well, I'm interested in the IQ score of 85. So 85 should be back here somewhere. I don't have to be exact with this. I just want to make sure that I mark 85 to the left of 100. Now remember, they want to know the probability, but the probability means find the area under the curve. So I'm really going to try to find this area less than 85, which means I'm trying to find this red shaded area to answer this question. So this area that I just shaded in is the answer to our question. But how do you find the area under the curve? That's where Excel comes in. So let me go to Excel and let me bring up a workbook that I sent out that will help us out here. I think I emailed this to everyone, and also this is posted in course announcements. So if you want to download this Excel file, please do that. Okay. So here is the command we're going to be using to find these areas under the curve. Here it is. It says equals norm.dist. So what that says is you want to go into Excel and type in this command, equals norm.dist. All right, then in parentheses, I got to put some numbers. Well, the first number is called the X value. The X value is really whatever measurement you're interested in for the problem you're working on. In our example, it's IQ scores, right? So X is measuring IQ scores in our example. So X is IQ scores. But what specific X number are we interested in? We're interested in this IQ score 85. So I'm going to type in 85 here for X. Next, it wants the mean and the standard deviation. Well, that was given to us in our problem. The mean was 100, and the standard deviation was 10. Then there's one more indicator, one more item you have to type in. It's just going to be the word true. The word true is telling Excel to use this function as a cumulative distribution function. So what Excel is going to do is going to add up all of this area going to the left. That's what cumulative means. So for our purposes, we're always going to be using this true here. All right, so let me type this into Excel, and let's see what answer we get here. So I'm going to come over here into Excel, and I'll come right over here. Let's say, if you can see my mouse, I'm going to type in equals norm.dist, left parenthesis, 85, 100, 10, true. Okay, and now I'm just going to hit enter on my keyboard. So I'm going to hit enter, and when I hit enter, Excel is giving me this answer of 0.066. So I'm going to round that to 2 decimal places. So we're getting the answer here of 0.067, let's say, if I round it. So this answer is 0.067. Really what that's telling me is there's a probability of about 6.7% that someone will have an IQ score less than 85. Well, that's a pretty low probability, right? That's a pretty low percentage. So it means very, very few people I expect to have a low IQ score at less than 85. Now, if anyone wants to try this themselves, you can bring up Excel on your computer. And if you want to try this command, I'll click my mouse here so you can see it one more time. I'm going to click my mouse so you can see what I just typed in. Feel free to try this yourself and see if you can kind of duplicate what I just came up with here.
I have a Chromebook and it has Sheets, which is a little different than Excel.
Yeah, now I think Sheets is going to have...
It gave me an NA when I did it, when I tried doing it.
Okay. Now, Gypsy, there is an equivalent command in Sheets.
I mean, it had that command there. I mean, it's one of the commands in the functions and the statistics.
Oh, it did. Okay.
Yeah.
And are you sure you typed in with commas in between?
Yeah, I'm pretty sure I did it a couple times. I'm pretty sure. But I don't know. With me, you just never know. I'm so tired all the time.
Let me do this. I'm going to do a quick check. Hold on one second.
I mean, after all, I kept getting 118 for that. And that was on 2 different calculators.
When you say 118, what do you mean?
On that problem 3, that was supposed to be 217. I kept hitting 118 when I was adding it up.
Oh, okay. So you're talking about a different example. Now,
Yeah.
were you adding up the same numbers that I was in my email?
I was adding up the numbers that were on the question, and so they weren't the same ones on that one piece of paper, but they were supposed to add up to 217, and they
Yeah.
They did.
Did you see my email with the numbers to add together?
Yes. Yeah, that's what I was working off of.
And when you type
Those
those
numbers were different. Those numbers were different.
Yeah.
What
Michelle,
I had.
Michelle, I'm going to take a quick time out for just 1 second, if you don't mind, Michelle. I just want to try to answer Gypsy's question here.
Not a problem.
I got it all figured out. I did that whole section already, and so that was, I don't know where I got my signals crossed on that bit.
Okay. Now, Gypsy,
But
were you...
I did numbers on what you did on that chart.
Well, these numbers that I'm showing you here are the same numbers that you showed me. So these are the numbers you gave me right here.
No, those are the correct numbers there. Yeah.
So I took...
Go ahead.
I took your numbers right here,
Uh-huh.
and I went up here and I multiplied each number times its probability. So this is your example that you sent me.
Because I have one that says, I have an email from you that says problem number 3, and in it you have 0.87 and 0.39 on it.
Now, in a different email, it might have been a different example. So I might have been doing a different example, because every time you go into...
That's what got me messed up, I guess.
Yeah, but now, Gypsy, let's just look at this email only. Because this email that I'm looking at right now is your example.
Yeah, and it adds up to 217.
So were you getting these numbers right here when you were doing it yourself?
Yeah.
Okay. And does this calculation up here make sense?
Yes, it all makes sense now.
Okay. So you're okay with this one, you think?
Yes.
Okay, good. Excellent. All right. So let me go to Google Sheets. So I'm just going to type in norm.dist. I just want to see if there's anything different about Google Sheets that would... No, it looks like it's exactly the same. Okay.
I can actually get. I have another laptop that I've just bought that's got Windows on it, and then I can actually the university provides Excel.
Oh, here's, wait, I think I see the difference. I think I see. Gypsy, in Google Sheets, do you see the command is norm dist without a dot in between?
Oh, now maybe that's, well, I used their command. I used theirs. I just clicked on it. So
Okay.
I didn't put, then I just put the numbers in after that. But
Okay. All right.
I can get a, you know, and Windows has a window that pops up and you fill it in with the different mean and stuff like that. Mine won't do that.
Okay, you can, so you can either use the command as by typing in yourself, or you can go up to formulas here. So if I come up here to insert formulas, and I can, let me show this to you. So I'm going to come up to the top here, and I clicked on insert formulas. And if I come here to more functions and go under statistical and scroll all the way down on this list, there's a norm.dist right here. And if I do that, it makes it a little nicer because now it prompts me to enter the numbers in separately. So if I did it in our example, our X value was 85, the mean was 100, the standard deviation was 10, and this cumulative, we're always going to use true. And if I hit OK, you can see here I'm getting the same answer. So whether you use that built-in function or you just type it in yourself, of course, it doesn't matter. That's totally up to you. All right, so let me mention one other item about Excel. Because sometimes you might want to know the probability that a measurement is greater than a certain value. So let me go back to my IQ example. Let me clear the screen here. So let me go back to my IQ example. Again, the mean is 100 and the standard deviation is 10. But now I'm going to change the question. Now the question is, what percentage, I'll say what probability, what's the probability that a random person has an IQ score above 110? Okay, so remember, when I want to find probability, that's analogous or the same as finding the area under the curve. So let me go mark the area under the curve on my little diagram so I can be clear what I'm trying to find. Well, here's the mean 100. And in our example, we're talking about scores above 110. So 110 maybe is over here somewhere. But above 110 means I want to find this blue area going to the right. So this is the area I'm trying to find using Excel. But here's the problem. This norm.dist command only finds areas going to the left. So norm.dist would find this area going to the left. So norm.dist goes to the left. But I want to go to the right. My area is going to the right. So here's a little trick you can use. It turns out that the total area under this normal curve is always 1. So if I could find this area going to the left, if I subtract that from 1, that must be the leftover area going to the right. So a little bit of a shortcut is you can type in 1 minus norm.dist. And now in parentheses, I'm going to put 110, comma, 100, comma, 10, comma, true. So this
So basically, whatever the answer is, you just subtract 1?
Exactly. That's the way you find area to the right under these curves. Let me say that one more time because this is a little confusing. When you use this norm.dist command, it only gives you areas to the left of a certain measurement. But if you want the area to the right, what you could do is
Pickles.
subtract from 1.
What do you want?
Let me give you just a quick example of that just to make it clear. Let's say in an example, I wanted to know this blue area here. But I know I can use norm.dist to find that this area going to the left is 0.80. Well, if that area going to the left is 0.80, it must mean that the area going to the right is the other 0.20. Remember, the total area under the curve is always equal to 1. All right, so let's do my example. Let's find, let me erase this, erase that. I'm going to come here and let me find, okay, I'm going to get rid of this and this. So here's what I'm going to do. I'm going to type in equals 1 minus norm.dist. Again, the reason I'm using the 1 minus is because I want to find the area to the right. Norm.dist is going to give me area to the left, but by subtracting from 1, it's going to give me kind of what's left over as the area to the right. So in our example, it's going to be 110, comma 100, comma 10, comma true. And it looks like the answer turns out to be 0.159. So this area going to the right here turned out to be 0.159. So the answer to my question is 15.9% of people have IQ scores above 110. Does that make sense?
Totally.
Now, if I was, let me just do the norm.dist command without the 1 minus in front. So I'm going to come up here and just do equals norm.dist of 110, comma 100, comma 10, comma true. What I'm going to do now is find the area to the left of an IQ score of 110. When I work that out, it's 0.841. So that 0.841 is this area going to the left. And of course, if you add these two numbers together, the total is 1.
Yeah. You think you just do some simple subtraction there?
Exactly right. Yep. You could just go on your calculator and take this number and subtract from 1. That would give you this answer that we were interested in this example. All right, well, in this Excel spreadsheet are some worked out examples. Let me just show you here in the Excel spreadsheet. Here are some examples like we just worked out a few minutes ago, so you can kind of use these as kind of a template. So notice here, this example was finding an IQ score less than 115. That's the norm.dist command to use. And here's the answer if you work that out. Here's an example of more than 104. Well, more than 104 means I've got to use norm.dist, but subtract from 1. And here's the answer to this example. All right, well, let me give you a few more comments and then we'll go to the homework. You know, it turns out that besides using the normal distribution like we just were, you know, we just did an example for IQ scores. There's all, and you know, in our example for IQ scores, we use the mean equal to 100 and the standard deviation was equal to 10. Okay. There's another normal distribution. It's called a standard normal distribution. And notice here it says a standard normal has a mean of 0 and a standard deviation of 1. So there's a special normal distribution called the standard normal that always has a mean of 0 and a standard deviation equals 1. When you work with the standard normal, this applies to something called z-scores. You might remember z-scores. We kind of worked with z-scores back earlier in the course. So whenever you're working with z-scores, what the z-score tells you is how many standard deviations you are away from the mean. Let me give you an example of using a z-score. Let's say I'm taking a test. I'm taking a biology test. And let's say the mean score on the biology test was 60. It was a very difficult test. So the mean score was 60. And let's say the standard deviation was 5. All right, but let's say my score turned out to be a 70. I actually did amazingly well on this test. So let's say I go home and I say to someone, hey, I just scored a 70 on my biology test. And they say, oh, you didn't do that good. I say, no, I did really, really good. And they say, how could 70 be a good score? Well, I have to tell them the mean was 60. So getting a 70 was really very good. Well, it would be better to communicate a z-score. You might remember a z-score, the way you calculate a z-score is you take whatever measurement you have, subtract the mean, and divide by the standard deviation. In my example, if I wanted to calculate a z-score for my score of 70, I would take 70 minus the mean 60 and divide by the standard deviation 5. I'm just using the mean of 60 and standard deviation of 5 for this biology test. Well, this would be 10 over 5, which is 2. What that's telling me is I scored 2 standard deviations above the mean. Well, that's a very, very good score. It means I was well above just about everyone else taking this test. I'm like the top of the class. But if I communicate a score of 70, it doesn't really communicate that. 70 kind of sounds like I didn't do that well. But if I say a z-score of 2, that tells me I did very, very well. So that's what we're plotting on this standard normal. We're plotting z-scores. All right, so let's go to this example. It says here, Joan's finishing time for a race was 1.81 standard deviations faster than the average for her group. Well, that tells me that the z-score is 1.81. Because if I'm 1.81 standard deviations above the average, that's exactly what a z-score is. So a z-score is how many standard deviations you are away from the mean. So in our example, the z-score is 1.81. Okay, well, let me draw a little normal plot here. Here's the normal plot, but this is going to be a standard normal distribution. How do I know to use this standard normal? Well, when they give me standard deviations above the mean, I know that's a z-score. And anytime I'm plotting z-scores, that's a standard normal. So the mean is 0. Remember, for a standard normal, you always write down that the mean is 0 and the standard deviation is 1. So they're telling me the z-score is 1.81. So I'm going to mark that here. Here's 1.81. Okay. It says, assuming a normal distribution, which we're doing, how many women ran faster than Joan? Now, they're also telling me there were 410 women in this race. Well, I'm going to break this down to two separate questions. Question one is find the probability that someone was faster than Joan. And then step two will be apply that probability to the 410 women. Well, if I'm trying to find a probability for the normal distribution, this really means find an area under the normal curve. But if it says faster, the faster z-scores are going to the right. These would be slower scores. These would be faster. So really what this problem is asking me to do is find this blue area. All right, well, that's where Excel comes in. If I want to find this blue area, I'm going to go to the norm.dist command. My measurement is 1.81. Now I need to enter the mean and the standard deviation, but I know the mean is 0, standard deviation is 1. And I'm always going to put a true out here. All right, but I know the norm.dist command is going to give me the area to the left. So I want the area to the right, so I'm going to have to do a 1 minus kind of subtraction. All right, well, I'm going to go to Excel and get Excel
Where do
to
you
do
put
this
the
for
1
me.
minus at?
Sorry?
Do you put the 1 minus after the true, or do you put it before?
Oh, if you're going to do this in Excel, the way you would type this in, let me write this up here on the slide. So in Excel, if you want to get Excel to do the subtraction for you, you type in equals 1 minus, and then put the norm.dist command. Okay? You don't have to do it in Excel, by the way. You could get the norm.dist result and then do the subtraction on your calculator. So let me show you how you could do this in Excel. Let me come over here. All right, I'm going to enter equals 1 minus norm.dist. The z-score they gave us here is 1.81. The mean is 0, standard deviation 1, and I'm typing in the word true. Now, because I typed this into Excel using a 1 minus format, this is going to give me the area to the right. So if I hit enter here, it's giving me 0.035 as this area to the right. So this area going to the right, this area is 0.035. What if I had only used the norm.dist command without the 1 minus in front of it? So let me do the same command, but I'm not going to put the 1 minus.
Would it give you that whole area to the left?
Exactly right. That's it. Yep, that's what I wanted to show you, Gypsy. Exactly. So now what this is going to do is give us the area going to the left. So the area to the left is 0.965. So this area to the left is 0.965. That would be this entire red area here. And then if I wanted to, I could just go to my calculator and work out 1 minus 0.965 on my calculator. And of course, I would get the answer of 0.035. So I could either do the subtraction using Excel, so this includes the subtraction, or you could do that separately on a calculator. That's totally up to you. All right, but that's not the final answer to this problem, because we just found the answer here was 0.035. They want to know what, how many women ran faster. So to find out the number of women that ran faster, I'm going to take the number that I started with, which is 410, and multiply that 0.035. Because remember, what this is telling me is about 3.5% of women ran faster than Joan. So I would multiply 3.5% times 410 in order to get the actual number. So if I work this out on my calculator, I'm getting the answer 14.35. But they're telling me to round to the nearest whole number, so I'm going to round this to 14. So my answer here, my final answer after all this work is 14. So I would expect only 14 women would run faster than Joan out of 410. So Joan did very, very well in this race, right? Only 3.5% of women ran faster than Joan. Joan ran faster than 96.5% of all the other women. So, folks, the key to this problem was recognizing that when they told you the number of standard deviations above the mean, that's giving you a z-score. Because that's the definition of a z-score. The definition of a z-score is the number of standard deviations away from the mean that a measurement is. And if it's asking me to use a z-score, that's where I use the standard normal distribution. Right? Notice over here in the spreadsheet it says a standard normal distribution is based on z-scores. And also notice it says here a standard normal distribution is a mean of 0 and standard deviation of 1. Folks, any questions on this example?
Nope.
Nope.
All right. Let's go to the next one. Let's come back to that one. Let's come to number 5 here. Number 5 is a little tricky. And, you know, part of these problems is really reading through all of the information they give you and trying to extract what you need to answer this question. All right, so if I read over here, this problem carefully, they're telling me here that some students get a scholarship when they go to this university, okay? And it looks like there were 5,348 students total. And they're giving me this information here. So let me explain what this means. They say N parenthesis 3446, comma, 473. All right, now we have to understand, what is this really saying? When you see N, this is telling you it's a normal distribution. The first number is the mean, and the second number is the standard deviation. So it's a little confusing, but you had to understand that they're telling you that tuition costs follow a normal distribution. Here it is. So this is tuition. Oh, I'm sorry, this is not tuition. This is the amount, this is the scholarship they received. So this is really the actual scholarship, tuition money that they received from the scholarship. So the average student gets $3,446 as, you know, a scholarship amount. All right, so let's see what they are asking us here. It says the full cost of tuition is $4,000. So I'm going to mark 4,000 here. This is the full cost. What percentage of students did not get the full tuition? So the word not here is important. Do you think they're asking me in this example to find the area to the left of 4,000? I'll shade that in red. Or do you think they're asking me to find the area to the right? I'll shade this in blue.
To the left.
The left.
The left. Good. Exactly right. Yeah, exactly correct. The area to the left, because these are the students that got full tuition in blue. But they're asking us what percentage did not get enough to cover full tuition. So we want the area to the left. So we want this red area. Well, Excel comes to the rescue. We want the area to the left of 4,000. We know the mean, we know the standard deviation. So I'm going to use the norm.dist command as is. I don't have to subtract from 1 because I only subtract from 1 when I want to find the area to the right. So the answer to this question is going to be equals norm.dist. I got to put the x value. The x value is the amount of the scholarship, which is $4,000, comma the mean, 3446, comma standard deviation, 473, and I always use the flag true. So I'm going to go to Excel and work this out. I'm going to come over here. Let me type it in, equals. Again, you might want to try this yourself if you have Excel handy. Norm.dist. The x value they gave us is 4,000. That's the cutoff to get full tuition. Comma, the mean they told us was 3446. Comma, 473 was the standard deviation. And I always use the word true. I'm just going to hit enter. And I'm getting the answer here, 8.88. So this area going to the left looks like it's 0.8842. All right, but they want me to round. First, they want me to change it to a percentage. So this is going to be 88.42%. But then they want me to round to the nearest whole number. So the final answer on this one is going to be 88%. Okay, so I come here and type in 88%. Maybe we should try it just to make sure we're okay. Check my work, and it looks good. You know, I might want to know this if I'm a parent and I'm thinking of sending my student to this university, right? 88% of students are not getting a full scholarship. Now, I know if the area to the left is 88%, it must be that the area to the right must be the other 12%. So this area is 88% going to the right, 12% must be going to the right. Excuse me, 88% is going to the left, 12% is going to the right. That means only 12% of students are getting full scholarships to this university. I might want to, you know, compare this to other universities. Yep, go ahead.
I said it must be Ivy League.
Yeah, this must be, you know, some kind of a selective school maybe where they don't have to give out that many full scholarships. But all right, so this was just an example of applying the norm.dist command. All right, any questions on this one?
So anytime we see n parentheses, one number, comma, another number, is that always the mean first and the standard deviation second?
Exactly right. The
Okay.
n is telling you it's a normal distribution.
Okay.
The first number they give you is always the mean. The second number will always be the standard deviation.
And if it's U, that means uniform distribution?
Exactly. Putting a U
And then the
in
first
front.
number would be the lower end and the second number is the higher end?
You got it. Exactly
Okay.
right. Yeah.
All right, perfect.
Yeah, part of the challenge on these problems is kind of, you know, steering through the notation. Because, you know, it's not obvious that in parentheses, one number, comma, another is telling you about the mean and standard deviation. It's a little confusing on the notation.
That definitely got me caught off guard. I didn't know what that meant.
Yep. All right. Let me. All right. Let me go to another part of using the normal distribution. All right, so this was finding areas under the normal curve, right? So, you know, we just did an example with IQ scores, let's say. And I'm going to go back to IQ scores for a second. The mean was 100. And we used the norm.dist command. And we use this to answer a question: what's the probability that someone has an IQ score of less than 90, let's say, right? And in this example, we would say norm.dist 90, comma 100, comma 10, comma true. So again, we're assuming that the mean is 100 and the standard deviation equals 10. All right, well, in this case, what we started out with was an IQ score of 90. Here's an IQ score of 90. And we wanted to find this area under the curve. Right, so norm.dist gives you an area under the curve. Does that make sense?
Yes.
That area is the same as a probability. So area and probability, area under the curve and probability really mean the same thing. All right, but now I'm going to give you an opposite kind of question. Here's an opposite kind of question. What IQ score puts you in the bottom 25% of people? What IQ score puts you in the bottom 25%? For this new question, here's a new question. Notice I'm asking you for the IQ score. So this is like the unknown quantity. What I'm giving you here is an area under the curve. Can you see this is kind of a backwards kind of question? Instead of giving you the IQ score of 90 and asking you for the area, I'm now doing it backwards. I'm giving you the area of 25% and asking you to find the IQ score. So what that question would look like is, here is the normal curve. The bottom 25% would be this red area. So this red shaded area is known to be 0.25. And I'm asking you, what is this IQ score here? Well, the way to answer this question is with a different Excel command. Because really this is kind of like the opposite or the inverse of the examples we've been doing up to now. So I really want to do the opposite of norm.dist. I want to do the inverse of norm.dist. Well, it turns out there's a command. It's called norm.inverse, norm.inv. And what norm.inv does is you give it an area and it finds an IQ score. So given an area under the curve, you can find an IQ score. All right, here's the way you use it. It's equals norm.inv. Now what you have to give it is a probability or an area going to the left. So this number here is the area to the left of the measurement you want to figure out, comma, then you put the mean and the standard deviation. So in our example, in the example I just came up with, here's what I would type in. Equals norm.inv. Our area to the left is 0.25. The mean is 100 and the standard deviation is 10. If I was to type that into Excel, it would give me the IQ score that cuts off the bottom 25% of people. Let me type it in so we could see what answer we get. I'm going to come down here, equals norm.inv.
Did you put true in on that? No, you didn't, did you?
Yeah, we don't need true for this command. This command only needs 3 numbers. it needs the area going to the left. In our example, it's 0.25. Then it's the mean, 100, then the standard deviation, 10.
Yeah, I saw something like this on there.
Yeah, we're gonna do some examples in the homework in just a second. Let me hit enter. And I'm getting the answer 93.2. So 93.2 is giving me the IQ score. So what IQ score puts you in the bottom 25%? The answer is an IQ score of about 93. So if you take an IQ score and you score 93, you didn't do that well. You're in the bottom 25%, which means the other side must be the other 75%, 0.75 going that way. Let me give you one more example, and then we'll go to the homework. A common question you might get is, what IQ score would put you in the top 10%? What IQ score puts you in the top 10% of people?
Would you do it the same way?
Do it the same way, but there's a little trick here that we got to think about. First, I'm going to draw a little curve, a normal curve, because that always helps me. Here's the mean of 100. The top 10% would mean the area way up here. So this area up here is 10%. But when I use this norm INV command, I've got to enter the area going to the left, not the area going to the right. So this area of 0.10 is the area going to the right.
Can you use a -1 again?
You got it. Do a -1. That means the area to the left must be 0.90.
Yeah.
So that means when I go to work this out using the norm INV command, I can't use 0.10. Instead, I have to use 0.90. So the way I'm going to work this out in Excel is equals norm.inv
Oh.
0.90. Remember, this always has to be area to the left. This is a common mistake. Comma 100, comma 10. So let me work that out in Excel. So
the comparison, the comparative in.
Norm.inv 0.90, comma 100, comma 10. Okay, I'm going to hit enter, and I'm getting the answer of about 113. So this IQ score would have to be about 113 in order to be in the top 10%. So if I take an IQ score and my score turns out to be 113, I'm a very smart person.
Yes, you are.
I'm in the top 10% of people taking IQ scores. Now, here's another reason why this diagram is such a good idea. So notice this diagram I sketched out. I know that my answer here to be in the top 10% must be greater than 100, right? 100 is like the average score. But if I'm going to be in the top 10%, my score has got to be much, higher than 100. What if I made a mistake? What if in the norm.inv command, I accidentally used the area to the right by mistake, and I put in 0.10 here, which would be wrong. But what if I did that by accident? I would get the answer 87. But then I would
Did you just subtract it from the mean?
Well, no, I just wanted to show you that if you did this, your answer would be here, but you should say to yourself, wait a second, that doesn't make any sense.
Yeah.
That can't be valid.
Yeah,
I can't have I can't have a score of 87 and be in the top 10% because a score of 87 is to the left of the mean. If I score 87, I'm below average. So I just want to point out to you why a diagram is a good idea, because it gives you a way to kind of sanity check your answers.
So what if the mean isn't given?
In this kind of question, the mean really has to be given in order for you to answer the problem. The mean and standard deviation both have to be given to you in order to answer these kinds of questions. The only exception might be is if you were given the diagram like this. Let's say they gave you a diagram like this, and they showed you this number was 53, and they didn't tell you the mean. Well, by looking at the diagram, you could say, wait a second, the mean must be 53, because the mean is always the number that corresponds to that peak. So if they gave you a diagram like this, you could use the diagram to determine the mean. But somehow you have to know the mean and standard deviation to answer the kinds of questions that we are talking about here. All right, why don't we go and do a few examples and connect here. So let me go back to number
I gotta get
4.
ready to go to work in a minute.
Okay, all right, let me go. Gypsy, is there any question you want me to jump to right away before you have to go?
No, we're okay.
All right, and remember, you can go back later and watch the recording of this.
Yeah.
Okay. Let's see, I think we did this one. Oh, no, we didn't do this one. All right, so let's do number 4. Actually, you know what? Let me do number 6, because number 6 is very similar to what we were just talking about. So let's go to number 6. All right, and this one is really not asking you to work out any commands. What it's asking you to work out is the actual Excel command you would use. All right, so let's go to this one. It says, suppose X is normally distributed. So remember, when you see N 51, 3, the N tells you it's a normal distribution. 51 is the mean, and 3 is the standard deviation. How would you figure out an X value to get into the highest 25%? Let's use IQ scores to make this a little easier to talk about. What IQ score would get you in the highest 25%? Let me draw a diagram. Here's a diagram. The mean IQ score is 51. And they want to know what score would put me in the top 25%. Well, that's the top area of 0.25. So we want to know this score here. Well, I want to use the norm.inv command. But I know the norm.inv command must use area to the left. This 0.25 is area going to the right. So I need to know what's...
So 0.75?
0.75, you got it, good.
Okay.
So in our example, the norm.inv command would be area to the left, which is 0.75, comma, the mean is 51, the standard deviation is 3. Well, the only command that seems to match that is this first choice here. So that first choice looks like the correct choice. All right, let me go to this guy right here. Let's do the lowest 10%.
All right, I have to go. I'll see you later. Thank you so much.
Okay. Thanks.
Good luck, Gypsy.
Bye, Gypsy.
Bye.
Thanks for joining.
Well, thanks for having us.
Okay. All right, so let's do the lowest 10% now. Again, I'm going to draw a diagram for the lowest 10%. Here's the mean of 51. Well, the lowest 10% would be down here. So this area is 0.10. But that is the area to the left. So when I go to use the norm.inv command, this 10% is the area to the left. So I'm going to enter it as 0.10, comma 51, comma 3.
So it's the second one.
Second one, you got it. Good. So again, you got to really be careful here as to whether the area they're giving you in these kinds of questions is the area to the left or the area to the right. Because the norm.inv command only accepts areas going to the left.
Okay.
Let's go to the part B of this question, which is a little tricky, so I saved it for last. It says middle 65%. All right, so let me draw a diagram. Here, I think a diagram is very important. So here's what they're talking about. Again, the mean is 51. So they're talking about an area of 65%, and that area is centered in the middle. So I'm going to kind of draw that maybe with something like this. Here is the middle 65% of the area. So this area here in the middle is 0.65.
So wouldn't it be the half of 65 to the left of the mean and half of 65 to the right of the mean?
You got it. Exactly right. Yep.
Okay.
What we have to do first is let's figure out the area left over for the tails. What is the area that's left over to go in the left tail and right tail? Well, I know 0.65 is in the middle. So what's left over to go in these other areas? Let me, I'm going to call this area A and area B, let's say. Well, the area that's left over must be 1 minus 0.65, which is 0.35. But that 0.35 is split up into area A and area B. So if I'm thinking about area A, it's really going to be 0.35 divided by 2. And of course, area B is going to be the same. Area B is going to be 0.035 divided by 2. So I just got to be careful to make sure that I'm drawing a diagram like this to make it easy to work with. So that means there's 0.175 as this area. Maybe I'll do purple here. So this area is 0.175. And this area is 0.0175. All right, so they want me to find two numbers here. They're calling this x sub lower, and they're calling this x sub upper. They just mean like the lower and the upper numbers that I'm going to come up with. So let's do x sub lower first. Well, for that, the area going to the left is 0.175. So x sub lower is going to be norm.inv, and I already have 0.175 as the area going to the left. The mean is 51, the standard deviation is 3. So that's the lower bound. But let's find the upper number. Now the upper is a little tricky, because for this upper number, I know that the area going to the right is 0.175. I really have to figure out the total area then going to the left of that. Well, the total area going to the left is going to be 1 minus 0.175. And if I work that out on my calculator, that works out to be 0.825. Does that make sense? Because I want to find this x value right here. I know the area going to the right is 0.175, but norm.inv wants the area to the left. Well, if the area to the right is 0.175, the area to the left must be 0.825. So that means x upper is going to be norm.inv. The area going to the left is 0.825, and the mean is 51, and the standard deviation is 3. Okay, so I just got to be careful with these answers, and it looks like this third answer is the right choice. Again, I think a diagram like this is very important. so that you can kind of see the areas under the curve and, you know, determine what is the area to the left. Because again, anytime you use the norm.inv command, it only accepts the area going to the left of the measurement. Okay, any questions on this one?
No, the diagrams help so much.
I think so. I think because visualizing it is so much easier to understand than, you know, just talking about it or.
It makes it more logical.
Exactly. I agree. All right, let's do maybe one more, I think. All right, so why don't we do this one? This one's actually gonna be very similar to the examples we just did. So let's do a couple of these. Here's what they're telling me on this one. The weight of a Starbucks coffee is a normal distribution. The mean is 390 and the standard deviation is 9. So notice they're giving us the mean and standard deviation. All right, first thing I'm going to do is draw a diagram. Here's a normal curve. This is the weight of a Starbucks coffee. That's what we're measuring. The mean is 390, so I'm going to put 390 here. All right, they say what weight corresponds to the highest 10%? So let me sketch the highest 10% on my diagram. Well, the highest 10% would be this red area up here. So this is an area of 10%. The reason I knew to put it up here is it said it's the highest, right? The weights have to be the highest, which is all the way on the right side of this curve. But I know if the area is 0.10 going to the right, the other area going to the left must be the other 0.90. So for part A, the way I would answer this is type in equals norm.inv. I know I need the area to the left, which is 0.90. Then I need the mean. Here's the command that we're using. The mean is 390, and the standard deviation is 9. All right, I'm going to work that out quickly here in Excel. And again, I think a good reason to draw this curve is now you can do a sanity check on your answer. So the area to the left is 0.90. The mean is 390. The standard deviation is 9. And it looks like I'm ending up with the answer of 401.53. So 401.53 is this weight. So if you get a cup of coffee that happens to weigh about 401 grams, you have a cup that's very, very heavy compared to everyone else's cup, right? You're in the top 10% when it comes to the weight of a cup. And it makes sense that my answer should be above 390, right? Because I'm looking for the very heavy cups. What if I made a mistake? Again, I just want to show you that this is a good way to check for mistakes. What if I made a mistake and actually entered in the norm.inv command 0.10 as the area, which of course is wrong, but I wasn't paying attention, and I actually entered the area going to the right in the norm.inv command. That's going to totally mess things up, but I get the answer 378. But the answer
Well, that's the lowest 10%.
Right, exactly right. This is the, you're exactly right. This is the lowest 10%. In fact, this is the answer to another question. Right, but if I was trying to come up with this is the answer for the top 10%, this would definitely be wrong because notice it's lower than 390. It turns out this is the answer for part D, right?
Mm-hmm.
Because part D of this question says, find the weight that cuts off the lowest 10%. Yep, good work to recognize that was the lowest 10%, exactly right. All right, let me do one more here. Let's do part B, because that's just a little different than these other parts. So part B says, what weights would cut off the middle 50%? Well, really what that's asking me to do is put an area of 50% in the middle. So the mean is 390. So in our example, they gave us the mean was 390 and the standard deviation was 9. All right, so they're asking me to put an area of 0.50 in the middle. So here is the area of 0.50 centered here in the middle. What I want to do, though, is I want to find what are the areas in this section A and B. Well, I know the leftover area for areas A and B must be 1 minus the area in the middle. So that's 1 minus 0.5, which means together area A and area B must add up to 0.5. But that must mean area A is 0.5 divided by 2. Because this 0.5 here is evenly split for the lower and the upper tail. So that's 0.25, and of course area B is going to be the same thing. So I know these blue areas are 0.25. All right, so let's find the lower cutoff. I'll call this number x sub lower. And then we're also going to find this x sub upper. Well, for x sub lower, the area going to the left is 0.25. So to find x sub lower, that's going to be norm.inv. The area to the left is 0.25. The mean is 390. The standard deviation is 9. How about x sub upper? Well, the upper, the area going to the left for x sub upper, let me draw that down here.
Would it be 0.75?
You got it, 0.275. Yep. Because if this area is 0.25 going to the right, it must mean the area to the left has to be 0.75. Yep, good work. So this is going to be norm.inv. The area going to the left is 0.75, 390, 9. All right, and then Excel will do the rest for me. So I'm just going to go into Excel and type in equals norm.inv 0.25. This is going to be the lower bound, right? 9. So this is x sub lower here. And then for x sub upper, I'm going to do norm.inv, but now the area is 0.75. And these are the two answers. And they want us to round these to 2 decimal places. So I'm going to take these two answers. In this box, I'll put the answer 383.93. And in this box, I'll put the answer 396.07. And by the way, Michelle, you probably know this already, but you know, for each one of these parts, you can do this check my work. So when you answer, let's say I just want to answer part B. I just want to check if that answer is correct. So I can enter 383.93 and 396.07. And I didn't do the other parts of this problem yet, but I just want to know if that answer is correct before I do anything else. Whoops, I think I typed that in wrong. 396.07 here. Whoops. And if I say check my work, oh, I put commas in between. Oh my gosh, that was bad.
That's how I always find out like I made a silly or simple mistake.
That's embarrassing. Don't tell anyone about that.
You are being recorded, so.
I know, that's the bad thing about recording. Now I'm going to do check my work. Now it's okay. Good. But notice I could check my answer on that part of the question.
Yeah.
Then go back and check the other parts. You know, I could do it one at a time. This way, if I get an answer wrong, I can kind of fix it before working the other parts. All right, any questions here, Michelle, on any of these examples?
Not on the ones you've did so far.
Okay.
I'm able to now go back to the ones I had issues with and correct my work. The two that we haven't discussed just yet is number 4 and question number 8, which I think we've discussed number 8 where I should be okay with
Yeah.
number 8, but number 4, it only gives the top 23%, but no mean.
Yeah, let's do this one. Good. Let's go number 4. All right, so let's read this over carefully. It says here, high school students compete in some kind of a challenge exam. Students who score in the top 23% are recognized with some kind of an award. Assume a normal distribution. How many standard deviations above the mean does the student have to score? You know, let me go back to a question that we did a few minutes ago. If you remember this example, remember it gave us 1.81 standard deviations above the mean. And what we said on this one is anytime you're talking about the number of standard deviations above the mean, or the number of standard deviations away from the mean, this is a z-score kind of question. Because that's exactly what a z-score measures. Z-score measures how many standard deviations are you away from the mean. So in this example, because we recognized this was a z-score tells you to use the standard normal.
And the mean would be 0 and the standard deviation 1.
You got it. Good. So let's go and do number 4 based on the standard normal distribution. Okay. And again, the way I would know that is when I read the question, it says, how many standard deviations above the mean do you have to be to get an award? When I see that wording, standard deviations above the mean, that really refers to a z-score, because that's the definition of a z-score. But if they refer to a z-score, that means standard normal. So again, I'm going to draw a diagram. A diagram is always a good idea. In this case, I'm plotting z-scores. All right, so they say you have to score in the top 23%. Well, the top 23% would be this area up here. So this is an area of 0.23. And they want me to find this z-score here. That's the question. All right, but I know if the area going to the right is 0.23, I really need the area to the left in order to use the norm.inv command. Well, if the area to the right is 0.23, and I remember that the total area under the curve is 1, that tells me the area going to the left must be 1 minus 0.23, which is 0.77. All right, but what about the mean and the standard deviation? Well, like you said, we're going to use a mean of 0 and a standard deviation of 1. So I think that gives us everything we need for the norm.inv command. Here's how we'll do it. Equals norm.inv. It wants the area to the left, which is 0.77, comma, the mean is 0, the standard deviation is 1. And by the way, remember that when you plot a standard normal, the mean is always 0. So I'm going to put a 0 here. My answer better be a number greater than 0. If my answer was a number less than 0, that would be a flag that I must have messed up somewhere. So let's go to Excel and type this in and see what we come up with. Maybe I'll come up here to the top and I'll type in equals norm.inv. Again, I need the area to the left. That's 0.77, 0, 1. And I'm getting a z-score of 0.7388. So this z-score is 0.7388. Looks like they want me to round to 2 decimal places. So it looks like our answer here will be 0.74. It does make sense that our answer is to the right of 0. If my z-score turned out to be a negative number here, and z-scores can be negative numbers, but if my answer was negative, it would not make any sense for my answer to be in the top 23%. So the answer here should be a z-score of 0.74. We might as well check it, I guess, while we're here. 0.74. And it looks good. So yeah, so problem 3 and problem 4 ended up really referring to the standard normal distribution, because problems 3 and 4 refer to how many standard deviations are you away from the mean. And that really involves z-scores. And z-scores tell you to use the standard normal. All right, Michelle, any other questions here?
I think so. I'm going through the number 4 has different numbers than what the example you were just doing. So I'm just trying to work it out to see if I can plug it in.
Why don't you take a few minutes and do that? Take your time.
Okay.
See what
So
happens.
it's 19% on the homework. So it just has different numbers than
Sure.
what you were examples.
Yep.
So to the left would be 0.81.
Good.
So then the formula would be equal sign norm dot INV. The probability is 0.81, comma, the mean is 0, comma, the standard deviation is 1. So I'm getting 0.877. So I must have just did something wrong, because that's what I
Well,
thought.
now remember also you have to round your answer to 2 decimal places.
So 0.88. Yes, I got it right.
Nice.
Okay. I feel better with that one now.
Good.
I think you answered all the questions I had a hard time with, and I think once I go back and I fix the answers on the ones that I missed, I should be able to understand it better.
Great. If you get stuck, just email me or post the question in that there's like an extra help discussion board. Always feel free to post questions there.
So number 8, that would be using the dot I and the norm dot dist or the norm dot INB.
Hang on,
So
let me
that-
go to number 8. Let's take a quick look. All right, let's take a look at this one. So it says here, a tire pressure system warns a driver when the tire pressure is 26% below the target pressure. Suppose the target pressure of a car is 28 psi. So again, I'm going to draw a diagram. Okay.
Yep.
Now, you know, for part A, really they're just asking us, what is the warning for a car? And it says the warning is 26% below the target, and the target is 28. So part A is not really talking about the normal distribution yet. Notice part B talks about a normal distribution.
Okay.
But part A is just asking you to figure out what number would be 26% below the number 28. So for part A, I don't use the normal distribution yet, because this is really just like a calculation question. Don't use the normal distribution here. All right, well, how do I figure out 26% below the number 28? Well, first I'm going to find 26% of 28. You know, the word of usually means multiply.
Yeah.
So really what they're asking us is to take 0.26 multiplied by 28. If I work this out on my calculator, I'm getting the answer 7.28. But that's 26% of 28. But I want to know what number is 26% below 28. So for this target number, or the warning number, I should say, for the warning number, I want to take 28 and subtract 7.28.
Okay.
Because that'll get me a number that's 26% below. And if I work this out, I'm getting 18.72. So this is the warning level for the tire pressure. If the tire pressure gets below 18.72, it's going to send a warning of some kind. You might see this in your car, by the way. There's a little dashboard light that comes on that tells you when your tire pressure is low.
I think it looks like an upside down horseshoe or something.
Exactly. It's supposed to look, it's trying to look like a flat tire. You're exactly
Yeah.
right. Yeah, it looks kind of like a horseshoe. And you might say, well, when does that light come on? Well, it comes on when your tire pressure is below 18.72 pounds per square inch. Okay. All right, so that's that one. Let's go to part B now. Now, part B says, suppose tire pressure is normally distributed with a standard deviation equal to 3. What's the probability that you're going to get a warning? Well, let's draw a diagram of this. Sorry, my dog is barking here, but
That's okay.
let me do this. Let me just clear a little bit of screen here. All right, so let me draw a diagram. So now this is part B. And we're measuring tire pressure here. All right, well, really the mean is, they really didn't come right out and tell us here, but what they're trying to say is the mean is 28, because that's like the target that we're trying to have. So the mean tire pressure is 28. Right, when you go to fill up your tires, you would set it to 28 PSI because that's like the target.
Okay.
But of course, your tire pressure doesn't stay at 28. Sometimes it varies a little bit. It varies with temperature outside. Sometimes it leaks a little air and so on. So the standard deviation is given as 3 in this problem. Okay, it says if the average is equal to the target, so that's why we said the mean is 28, what's the probability that you're going to get a warning? Well, from part A, we know you'll get a warning when the tire pressure dips below 18.72. So really part B is asking you the question, what's the probability that your tire pressure is below 18.72? Does that make sense? Because if your tire pressure is below 18.72, you get the warning.
Yes.
Really what they're asking us to do then is find this blue area under the curve. But if I want to find the area under the curve, that's the norm.dist command. So to answer this question, it's going to be norm.dist. The x value that we have is 18.72. The mean is 28. The standard deviation is 3. And then remember, you always use this flag here of true. Now, norm.dist gives me the area to the left, but that's okay because that's exactly what I want. I want the area to the left. Does that make sense? That will give us the answer to this question.
So then C probably would be the 1 minus norm.dist.
Well, let's read number C, because number C I think is a little tricky. They're asking us to find the probability that your car stays in this recommended range. Notice here it says, what is the probability that the tire's inflation is within the recommended range?
So is that like the middle percent?
You got it. We want to find the middle percent. So let's talk about that because we haven't really done an example like that yet. Let me clear this. All right, so here's what they're asking us to find now. Here's our curve. We know the mean is 28. The lower limit for the recommendation is 26. The upper recommendation for the limit is 30. So this is really the recommended range. Your tires should be somewhere between 26 and 30 psi. What's the probability that you're within this range? Well, within the range means I want to find this red area in between here. So I need to find the red area. All right, now this is going to be a little tricky because Excel doesn't give you a way to find the area in the middle like this directly. But here's what we could do. What if we were to find area A? By the way, there's a couple of ways to do this. Let me give you one way that I think might be the easiest way. What if I find area A? What if I find area B? And then the area in the middle will be 1 minus area A plus area B. Let me see tell me if you think this makes sense. I'm going to find area A. Now, that's not really the area I want, but I'm going to find area A anyway. I'm going to find area B. That's not the area I want. But I know if I add those two areas together and subtract from 1, that leftover area must be the middle area that I do want.
Okay.
Does that make sense kind of visually?
Yes.
All right, so let's find area A. Area A is the area to the left of 26.
So that would be norm.dist 26. The mean 28, and then the standard deviation, which is 3.
Good. You got it. Good. Okay, and why don't we work this out as we're going along here just to make it a little more concrete. So I'm going to go here to Excel equals norm.dist. You said to type in 26, 28, 3, true. Okay, And so I'm getting that area A is 0.25249. Okay. Actually, let me round it. It says here, round your intermediate calculations and final answer to 4 decimal places. So why don't I should round this to 4 places. Let me do that. So this is going to be 0.2525, right? All right, so now why don't we find area B? Area B is the area to the right of 30. Well, for area B, I can use the 1 minus norm.dist. So for area B, this is the area to the right of 30, right?
1 minus norm.dist.
You got it. 1 minus norm.dist. 30, comma, 28, comma, 3, comma, true. All right, I'm going to let Excel do this for us. So I'll come over here. I'll type in equals 1 minus norm.dist 30, comma, 28, comma, 3, comma, true. Okay, and let me just mark it. This is area A, and this is area B in my diagram. You might notice it turns out to be the same area. I mean, the same result. What that tells me is area A and area B are kind of symmetrical. So they're equal to each other. All right, let me add area A and area B together. So I'm going to add these 2 areas. Well, that means I'm just going to take 0.2525 and add it to itself. And that's going to be 0.5050. Well, that means that the area in the tails is 0.5050. But I want the area in the middle. So the area in the middle is 1 minus that, because it's what's left over, right? The area in the middle is the area other than the area in the 2 tails. And if I work this out on my calculator, I'm getting the answer 0.495.
Makes so much better sense now.
So, what this is telling me is, given the mean and standard deviation that I have here, the probability that my tire is going to be properly inflated is about 49% probability. So it's kind of like it's a 50-50 chance that my tires are properly inflated or not. So let's enter this answer just to make sure we did this correctly. This problem, part C, is pretty tricky because you really had to see the 3 different areas here. There was area A, area B, and then the area in the middle. You wanted to find the area in the middle. So you found area A and area B, and then subtracted those areas from 1 to give you the leftover area. That was the area in the middle that you were looking for.
Got it. That was so helpful.
All right, sounds good. Give this a try. By the way, Michelle, keep in mind too, these homeworks are kept open even after the due date. So, even if you don't finish a homework by Sunday night, don't give up. You can always go back even on Monday or Tuesday and keep working in the homework.
No, I'm going back right now and I'm going to correct what I have. I'm a perfectionist, so
Good.
I'll
Excellent.
get it done.
Sounds good. Email me if you get stuck.
Will do.
All right. Well, thanks very much for joining.
Thank you for having us. I appreciate it.
All right. Sounds good. Talk to you soon.
Bye now.